worked with matrices and we added, subtracted, multiplied by constant, and solved some equations with these things. Today, we are going to talk about how to multiply. And multiplying does not work the same way as all the other operations. So you're not just multiplying corresponding numbers together. To multiply matrices, you actually have to take a row times a column. And so when we multiply a row and a column together, our answer is going to be a single number. So how this works is we multiply the corresponding numbers. So we do 3 times 3. We do -5 times 4. We do 2. Why is my board is a little delayed today. I'm making my handwriting bad. So we multiply these corresponding numbers, and then we are going to add all of that together. So we get 9 minus 20 minus 10. So when I multiply this row and this column, my answer is going to be -21. So if we are adding, subtracting, subtracting, or solving equations with matrices, the matrices have to be the same size in order for that to work. With multiplying matrices, because we have to take rows times columns, the number of columns in the first matrix has to be the same as the number of rows in the second. So this is pretty important. We can only multiply if the number of columns in the first one is equal to the number of rows in the second. Unlike other multiplication, order matters with these. Multiply the dimensions of the two matrices will show you the dimension of your answer. So in order for it to work, remember this is rows by columns. The columns in the first one, so if I have an m by n, that's n columns, has to equal the number of rows in the second one. If those are equal, we can multiply them, and the size of our final answer will be m by l. And I'll show you that with actual numbers and matrices in a second. So question for you. Could I multiply a 2 by 3 matrix with a 3 by 5 matrix? In order to multiply the number of columns in the first, has to equal the number of rows in the second. So we can't. So if I have a 2 by 3 and a 3 by 5, what I'm going to tell you to do is write down the sizes of them. If these numbers match, we can multiply. Our final matrix will be 2 by 5. So we could multiply these, we'll get a 2 by 5 for the final answer. Could I flip the order? Could I take the 3 by 5 times the 2 by 3? No, it would not work that way. So it only works the one direction on this. Alright, so our first step on all of these problems will be to write down our dimensions, make sure we can multiply, and figure out how big our final answer will be. So if I ask you to find A times B, I'll give you a second to write down those matrices before I start. So A, what's the size of matrix A? And matrix B?
3 by 4.
So can we multiply?
Yes.
Yes. If these inside numbers match, we can multiply. How big will my final answer be? 2 by 4. So my answer will have 2 rows, 4 columns. All right. When we do this, take a row times a column. So if I'm taking row 1 times column 1, that will give me the number in row 1, column 1. Right, so to multiply those, you multiply the corresponding numbers. So 2 times 2 is 4, plus 4 times 4, 16, plus negative 1 times negative 3 is 3. Okay, if you want to go ahead and add them, you can. I'm just kind of writing out my work to show you where these are coming from. All right, the next number. This is row 1, column 2. So to get it, I have to take the first row times the second column. So 2 times 5 is 10. 4 times 8 is 32. Negative 1 times 1 is negative 1. This is row 1, column 3. So to get that answer, I have to take row 1 times column 3. So 2 times 1 is 2, plus 4 times 0 is 0, plus negative 1 times negative 2 is 2. This is row 1, column 4. So to get that, we take row 1 times column 4. So 2 times 4 is 8, 4 times 6 is 24, negative 1 times negative 1 is 1. Does everybody understand where I'm getting my numbers? Okay. So this position, this is row 2, column 1. So to get that number, we are going to take row 2 times column 1. So 5 times 2 is 10, 8 times 4 is 32, 0 times negative 3 is 0.
So basically, we're just.
Oh, yeah, I said one thing and wrote another.
So basically, we're just foiling, but a little funkier.
Yeah, kind of. So this is row 2, column 2, so I take row 2 times column 2. So we get 25 plus 64 plus 0. Then we have row 2, column 3. So the second row times the third column. So 5 times 1 is 5, 8 times 0 is 0, 0 times negative 2 is 0. Last one, row 2, column 4. So second row, fourth column. 5 times 4 is 20, 8 times 6 is 48, 0 times 1 is 0. All right, a little more work. Does everyone understand where I got all my numbers? Okay, so then to finish it, we just add them together, and you may have already done that, that's fine. So we get 23, 41, 4. Second row would be 39, 5, and 68. Let's try another one. So, what's the dimension of our first one?
2 by 2,
And the second one?
2 by 4.
So can we multiply? Yes. How big will the final answer be? 2 by 4. So you can show as much or as little work as you need. I'll try to write it out at least for the first couple, so we're understanding where things are coming from. So row 1, column 1, row times column. 2 times 2 is 4, negative 2 times 3 is negative 6. If you want to go ahead and add those together, we get negative 2. All right, row 1, column 2. So 2 times 1 is 2, negative 2 times negative 1 is 2, 2 plus 2 is 4. Row 1, column 3. 2 times 4 is 8, negative 2 times 3 is negative 6. Add those together and we get 2. Row 1, column 4. 2 times 6 is 12, negative 2 times 2 is negative 4, 12 minus 4 is 8. So the first row is done. Now I need row 2, column 1. So 2 times 1 is 2, 3 times 0 is 0, so we get 2. Row 2, column 2. 1 times 1 is 1, 0 times negative 1 is 0, and we get 1. Row 2, column 3. 1 times 4 is 4, 0 times 3 is 0, we get 4. And row 2, column 4. 6 times 1 is 6, 0 times 2 is 0, and we get 6. You guys think you can try one? Here's yours. So can we multiply? Yeah. What's the dimensions of this one? And this one? So we can multiply, and our final answer is 2 by 2. So row 1 times column 1. So we get 1 plus -2 plus 6, which gives us 5. Row 1, column 2. So 1 times 2 is 2, plus 0, plus 12. Row 2, column 1. So we get 0, plus 1, plus 8, which is 9. And row 2, column 2. So we get 0, plus 0, plus 16. Get it?
Mhm.
All right. Let's do... dimensions of the first one. Second one.
2 by 3. Wait, 3 by 2.
So we can multiply. If I flip the order, would we be able to?
No.
No, and then you would just say it's not possible to multiply them. It's undefined. But we can. So this is going to be our last one. If we can get it, then I will let you guys work. So how big will the final answer be?
3 by 2.
Again, show what you need to on here. I'll try to show out all my work. So, row 1, column 1. Do you guys want me to let you try to work it on your own first? I'll give you a chance. No more. So row 1, did you get 9, 2?
Yep.
And row 2, 34, 13.
Yep.
And row 3, 47, 20.
And 48.
Do we need to go over this anymore? Do you guys understand what you're doing?
Yes.
Then that second Math Excel is